Good morning, viewers. This is Kasturi Day. Today, I'm back with the chemistry chapter, which I was discussing, chemical changes and reactions chapter. So, before I start, I will request you to please do subscribe my channel so that you can get the notification first and foremost. Okay, and if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. As I've started some new surprises for you all, simple tests and other things I will be coming up with. So you need to subscribe my channel and watch the videos constantly. Okay. So let me start with today's videos. And before that, before you start, let us meditate for 2 minutes. Okay. And then I'll start it. Okay. Be calm and think of anything, maybe any, whichever God you like, that will increase your concentration power, and also that will help you in getting interest in your studies and whatever you do the whole day. Okay, so let's meditate for a few seconds more. Okay, it's over now. So this will increase your concentration power, and whatever you do in the whole day, that will increase your interest in that. You practice this before the day, before you start your day, and also in between whatever you are doing. Okay, just for 1 to 2 minutes, and that will help you the whole day. Okay, so let me start with first today's which I have stopped there is the types of the chemical reactions which I was discussing there. So there are 5 types of chemical reactions: synthesis, direct combination, simple displacement, decomposition, and double decomposition. Okay. So synthesis reaction is the reaction in which when 2 different atoms or molecules interact, forming a different molecule or a compound, then it generally releases energy. Okay, and this type of reaction is known as synthesis reaction. So in the synthesis reaction, there is combination of 2 different atoms or molecules forming one or more one different molecular compound. Okay, and this type of reaction is exothermic reaction, that is releases heat. For example, when sulfur combines with oxygen, it forms sulfur dioxide. This is a synthesis reaction. In this reaction, there are reaction with the metals with oxygen, reaction with metals, reaction of non-metals with oxygen, reaction of metals with chlorine, non-metals with chlorine, metals with sulfur, non-metals with sulfur, metals with nitrogen, non-metals with nitrogen, and so these are the types of synthesis reactions. Here, metal plus oxygen gives us metal oxide. Okay, like this one, all the metals, they do not Silver and gold, they do not react with oxygen, but metals from copper, so potassium to copper, they react with oxygen to form their respective oxides. Okay. And when the reactivity, if we see the reactivity series, metal reactivity series, the reactivity decreases when it comes down from potassium to copper. The metal oxides are generally basic oxides, and few of them are amphoteric oxides. I told you basic oxides, they form, when they react with water, they form an alkali, which turns red litmus paper blue. Okay, and amphoteric oxides, these two oxides, they both behave as an acid as well as a base. Okay. Now, reaction with non-metals with oxygen, that also non-metals oxides are generally acidic oxides, and very few of them are neutral oxides. Okay. The non-metals react with oxygen to form non-metal oxides. So like carbon, sulfur, they burn in oxygen to form their respective oxides. Okay, and these non-metal oxides are generally acidic in nature. That is, they turn blue litmus paper red. Okay, the sulfur burns in oxygen with a pale blue flame. Then metals with chlorine when reacting, that is sodium reacting with chlorine, form sodium chloride. Salts are formed. Non-metals with chlorine, a compound like phosphorus combining with chlorine, it forms phosphorus pentachloride. Then metals with sulfur, for like zinc plus sulfur, it forms zinc sulfide. Then non-metals with sulfur, like chlorine combining with sulfur in boiling, that means chlorine is boiled in sulfur. Then what happens? Sulfur chloride is formed. Okay. And then sulfur monochloride, rather. Sulfur monochloride is formed. Then non-metals with nitrogen, metals with nitrogen. Metals come when burning in nitrogen, it forms metal nitride, or if they're heated, they can change into their nitrides. Like magnesium, burning in nitrogen, it forms magnesium nitride. Like that, calcium and aluminium also burn on heating, they form nitrogen. They form directly combines with nitrogen to form their nitrides. Okay. Then reaction of non-metals with nitrogen with non-metals like hydrogen, it combines to form ammonia by Haber's process, where iron is taken as catalyst and molybdenum as promoter, and 450 degrees centigrade to 500 degrees centigrade temperature is required for this synthesis reaction. Okay. Then nitrogen combining with oxygen in the case of thunder and lightning, where nitric oxide is formed. Okay. Next is, we come to the direct combination reaction. These I have discussed in my last video also. Just a recap of them, and some mistakes were there. I just wanted to rectify that one. Then direct combination reactions, a reaction in which two or more elements, they combine chemically to form a single product. It is similar to that of the synthesis reaction, or rather both of them are same. Okay, the difference is that, when we prepare something, when we are preparing something, then we call the reaction as synthesis reaction, and when there is just combination is taking place, that's a combination reaction. That is the thing, that is the main difference between them. Otherwise, it is all the same. Okay, both of the reactions are almost same. Okay. Then reaction of lower oxides with oxides to form oxygen to form higher oxides. That is, carbon monoxide is a lower oxide combining with oxygen, that's burning in oxygen with a pale blue flame, forming carbon dioxide. Sulfur dioxide is a lower oxide than sulfur trioxide. So sulfur dioxide is combining with oxygen in presence of vanadium pentoxide V2O5 in presence of 450 degrees centigrade temperature, and forming sulfur trioxide. Then another direct combination reaction is a soluble basic oxide with water. So soluble basic oxides react with water. We know basic oxides are generally metal oxides. So metal oxides react with water to form alkalis, which turn red litmus paper blue, like K2O, potassium oxide, combining with water forming KOH, calcium oxide combining with water forming CaOH whole twice. Then reaction with acidic oxide with water. And acidic oxide, we know acidic oxides are generally non-metallic oxides, or you can say these acidic oxides can be named as acid anhydrides. Okay, so they react with water, forming forming acids which turn blue litmus paper red, like carbon dioxide with water forming carbonic acid, sulfur dioxide reacting with water to form sulfurous acid, sulfur trioxide with water forming sulfuric acid, phosphorus pentoxide reacting with water to form phosphoric acid. Next we come to, this is the new thing which I will be discussing, rather from this, the today's new discussion will be starting. So this is the activity series of elements. Okay, so the activity series is like this, like potassium comes first, then sodium, then lithium, then calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, mercury, silver, and gold. Now, potassium, sodium, lithium, calcium, these react with water. Okay, ordinary cold water, they can react with this cold water. Then, as we come down, this reactivity decreases. Okay, that is when magnesium, aluminium, zinc, iron, tin, lead is coming, it reacts with hot water, or rather steam, you can say. Copper, mercury, silver, they do not react. Gold also, they do not react with water. Then reaction with acids, this potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, tin, lead, they all react with acid, okay, to form salt and water. Then no, not salt and water, they react with acid. Okay, that's not a base to form, or base to form salt and water. They form basic oxides, you can say, with water. Then reaction with oxygen. Okay, this from potassium to silver, all of them react with oxygen, but not gold. And for acids, copper, mercury, silver, gold, they do not react with acid. Then very reactive are the above ones, and very unreactive as we go down the series. Okay, so this is the picture. See, in between lead and copper lies the hydrogen. Hydrogen is a non-metal, though it is used as a comparison between the upper reactive metals and the lower unreactive metals. Okay, so the most reactive metals are potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. Okay, and then the most less reactive are copper, mercury, that is down the series below hydrogen. Less reactive metals like copper, mercury, silver, gold. Okay, their chemical reactivity decreases as we go down the series. Now, next we come the third reaction, chemical reaction, that is simple displacement reaction. Now, what is simple displacement reaction? It is a reaction, it's a chemical reaction in which more reactive element lying above the metal activity series displaces a less reactive element lying below the metal activity series from its compound. Okay, so the above, the element which is, or the other metal which is above hydrogen in the activity series will displace this less reactive element which is lying below the hydrogen from its compound. Okay, so it is known as a replacement reaction. Also, it can be called displacement, can also be called replacement reaction. Okay, so it will look like, that is, A will if the compound is BC, so the compound A will displace B from BC. So the compound that will be formed, if A plus BC, if it is the reactant, if they are the reactants, the compound will be formed, a new product will be formed, that is AB plus C. Okay, so like this. So it can also, metals that exist above hydrogen activity series displace hydrogen from water and dilute acids. See, metals which lie above hydrogen. in the activity series. They can also displace hydrogen from water. If there's water, then it can displace the hydrogen from there, and also from dilute acids also, hydrogen can be displaced by the metals which lie above the hydrogen in the activity series. Now, but metals that exist below hydrogen in the activity series, they cannot displace hydrogen from either water or dilute acids. Now, sodium, potassium, and calcium can displace hydrogen from cold water. From cold water, sodium, potassium, calcium can displace hydrogen. So sodium reacts with water to form NaOH and hydrogen is released. Potassium also KOH and hydrogen is released. Calcium also CaOH whole twice and hydrogen is released. Now, rest of the metals, besides this sodium, potassium, and calcium, rest of the metals which are lying above hydrogen, they react with steam, not cold water, but with steam to get their respective oxides, not hydroxides, but oxides, which and also liberate hydrogen along with it. So what happens? Magnesium with steam, it's not water, but with steam, it reacts to form magnesium oxide as the respective oxide and hydrogen is released. Like that, zinc also with steam, with zinc oxide and hydrogen is released. Iron, in case of iron, what happens? Iron has to also to be heated. Water, that is steam in the steam form, and also iron should also be red hot. Then only this iron will react with water to form ferric oxide, Fe3O4, ferric oxide, and hydrogen will be released. Okay. Now, copper, silver, gold, which lie below, etc., that is below the below hydrogen in the reactivity series, they do not react with water under any condition, neither with cold water nor with steam. Okay. Then another is metals react with dilute acid. I told you that metals in the activity series, they can displace hydrogen from dilute acids or water. So first water we have discussed. Now we come to dilute acids. The metals which lie above the activity series, they can displace hydrogen from dilute acids. Now how? Explosive reactions takes place when sodium, potassium, and calcium reacts with dilute acids, liberating hydrogen. So sodium, potassium, and rather potassium, sodium, and calcium, as they lie at the topmost part of the activity series, they are highly reactive metals. They will react with dilute acid explosively. That is, an explosion will take place when they react with the dilute acids and forming their salts with the liberation of hydrogen. Okay. Now, below calcium, that is magnesium, zinc, aluminium, all these magnesium, zinc, and aluminium, they also react with dilute acids. But here the reaction is not so explosive, but less vigorous. Okay, they react with dilute acids, forming their chloride and also liberating hydrogen, but they react in chloride or sulfate also, because dilute acids, it can be sulfuric acid also, or it can be nitric acid also. So they will react with their acids, forming their salts, and hydrogen will be liberated, but the reaction is not so vigorous, like the potassium, sodium, and calcium. Okay. Next, we come to iron. Okay. So iron, what happens? Iron, when it reacts with iron, dilute acids, when react with iron, it's a very silent and slow reaction. Okay, iron reacting with dilute acid, that is very silent and slow reaction is taking place. So iron, when reacts with dilute hydrochloric acid, then iron chloride, FeCl2, ferrous chloride, and hydrogen is liberated. When it reacts with sulfuric acid, it is not Ca, but it is Fe. Okay, please rectify, it's Fe. Dilute acids, then it will form FeSO4 and liberating hydrogen. Now, in case of copper, silver, gold, which are lying below the this one hydrogen, they will not react with the dilute acid to liberate hydrogen. Okay, so what do they form? The more electronegative element displaces less electronegative element from its salt solution. Okay, displacement can take place, but it will not displace hydrogen. It will displace less electronegative element. The more electronegative element is there, that will displace less electronegative element from its salt solution. So salt solution like potassium iodide, in case of halogens especially, that is fluorine, chlorine, bromine, and iodine, these are halogens. Okay, now potassium iodide, that is colorless solution, that will, this chlorine is a more electronegative element that will displace iodine from the less electronegative element. That will displace the iodine, that is a less electronegative element, displace this iodine from potassium, its salt solution, that is potassium iodide. Okay, so the salt solution will, the product will be formed as KCl, and iodine will be coming out as deep yellow color. Okay, then potassium bromide. Chlorine also can displace potassium bromine because chlorine is a more electronegative element. It will displace bromine, which is a less electronegative element, from its salt solution, KCl, and bromine will be displaced as a reddish brown gas. Okay. Okay. Then we come to decomposition reaction. Okay. Now, in decomposition reaction, what is that? It is a type of chemical reaction in which a single compound breaks into two or more elements. A single compound, it breaks into two or more elements by absorbing energy. This is an endothermic reaction. Decomposition reactions are generally endothermic reactions. Like that, like if effect of heat on metallic and non-metallic nitrates, like non-metallic nitrate is ammonium nitrate. Okay, when it absorbs it, it will break down to what? Nitrous oxide or laughing gas, and water will be formed. Okay, see the red triangle that indicates the heat absorption. Heat is required to break down ammonium nitrate to nitrous oxide and water. Then sodium and potassium nitrate on heating gives oxygen, that is liberates oxygen as the only gaseous product. No other gaseous product comes out. So the salt, this potassium or sodium nitrate, that decomposes into sodium or potassium nitrite, NaNO2 or KNO2, and oxygen will be liberated. Then all nitrates from calcium to copper, they decompose on heating, forming metallic oxide, nitrogen dioxide, and oxygen. In case of sodium and potassium, only oxygen gas is liberated. But in case of from calcium to copper, the gas liberated is two gases are liberated, that is nitrogen dioxide and oxygen. And also their respective oxides are formed. Like for case of calcium nitrate, it decomposes to calcium oxide, that's the oxide, and then nitrogen dioxide and oxygen. For zinc nitrate, zinc oxide, nitrogen dioxide, oxygen. Lead nitrate, lead oxide, lead monoxide, nitrogen dioxide and oxygen. Copper nitrate, copper oxide, nitrogen dioxide and oxygen. In case of silver and mercury, they decompose on heating to the respective metals, not to their metal oxide, to their metals, and also along with it, nitrogen dioxide and oxygen are formed. Okay, so mercury nitrate, okay, that decomposes into mercury, then nitrogen dioxide and oxygen. Then silver nitrate also decomposes to silver, nitrogen dioxide and oxygen is formed. Then another decomposition is effect of heat on metallic carbonates. Okay, so when metallic carbonates are heated, then what happens? The decomposition takes place or not. See, sodium and potassium carbonate, they are stable compound towards heat. They do not decompose on heating. Sodium and potassium carbonate. Okay, so mind it. Next is all metallic carbonates from calcium to copper. They decompose on heating to the respective metal oxide and carbon dioxide gases liberated, like calcium carbonate, magnesium carbonate, zinc carbonate, lead carbonate, copper carbonate. They all decompose to their respective oxides, like a calcium oxide, magnesium oxide, zinc oxide, lead monoxide, then copper oxide, and carbon dioxide gas is liberated. Now, in case of silver and mercury carbonates, on heating, they decompose into the respective metals, carbon dioxide, and oxygen is also liberated. So, in case of calcium to copper, the gas is only carbon dioxide that is liberated, and the compound that is formed, that is their metallic oxides. But in case of silver and mercury, what happens? Only the metal is displaced, metal comes out from this decomposition. Then two gases are liberated, carbon dioxide and oxygen. So mercury carbonate decomposes to mercury, carbon dioxide and oxygen, and silver carbonate gives silver, carbon dioxide and oxygen. Now, in case of metallic hydroxide, again, in case of sodium and potassium hydroxides, these two hydroxides are stable towards heat, that is, they do not decompose on heating. Whereas the other metal oxides from calcium to copper, they decompose on heating, forming their metallic oxides, and water is formed. Like CaOH whole twice gives us CaO plus H2O, magnesium hydroxide, MgO plus H2O, zinc hydroxide, ZnO plus H2O, lead hydroxide, lead monoxide, and H2O. Next is, this is copper hydroxide gives us copper oxide, and water is formed. Then silver, in case of silver and mercury, again, these two carbonates, these two hydroxides rather, these two not carbonates, these two are hydroxides, they decompose on heating to they form their metal, water, and oxygen is also liberated in case of silver and mercury hydroxides. Okay. The metallic bicarbonates, all the metallic bicarbonates, they decompose into the respective metallic carbonates, water, and carbon dioxide is liberated, like sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, not hydroxide, magnesium bicarbonate, calcium bicarbonate, sodium bicarbonate, potassium bicarbonate, they all decompose on heating to their respective carbonates. That is, sodium bicarbonate forms sodium carbonate, calcium hydrogen carbonate or calcium bicarbonate forms calcium carbonate, magnesium hydrogen carbonate or magnesium bicarbonate forms magnesium carbonate, water, and carbon dioxide is liberated. So all the metallic bicarbonates, they behave in the same way. Then thermal dissociation, another type of decomposition is there, that is by passing more heat. Okay, more heat, that is directly it decomposes, and it's a reversible decomposition. Why we call it thermal dissociation? Because it is a reversible decomposition reaction taking place only by heat. Absorbing heat is there. And this is must. That is, they must absorb heat to decompose into their respective, into their different compounds. But this reaction is a reversible reaction. That's why they are known as thermal dissociation reaction. Like ammonium chloride. Ammonium chloride on heating forms ammonia and hydrogen chloride. When they are cooled, they will again combine to form ammonium chloride. Then N2O4, okay, that also changes to reddish brown nitrogen oxide gas, nitrogen dioxide gas, and again this, if the gas is cooled, again it changes to N2O4. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. In the double decomposition section is left. Some reduction and oxidation reactions are left. Okay, some few reactions or some few chemical reactions are left. Okay, so I'll discuss in my next video. So till then, go through the videos. If you have any doubt, please do write in the comment box. Do share with your friends and colleagues so that they can also be benefited from these videos. And don't forget to subscribe my channel because many surprises are coming up. Okay, so you need to subscribe my channel to get those surprises. Okay, and don't forget to meditate before you start your day. And in between also, when you're starting a new subject, a new work to do, you please do meditate for at least 1 minute, 2 minutes. That will help you in your concentration, in your interest. It will increase. Okay, you will like it. You will remain cool the whole day. Magical benefits are there if you do the meditations. Okay, so thank you for watching and have a good day.